Example 5. If you pull a random card from a deck of playing cards, what is the probability that it is not a heart? So we know there are 13 hearts in the deck, so the probability of getting a heart would be 13 out of 52, which can simplify to 1/4. The probability of not drawing a heart is the complement. So we can calculate this by calculating the probability of not heart equals 1 minus the probability of getting a heart, which equals 1 minus 1/4, which is the same as 3/4, so 3 out of 4. Here's example 6. Suppose we flipped a coin and rolled a die, and wanted to know the probability of getting a head on the coin and a 6 on the die. So the first thing we could do is we could list all possible outcomes. This is shown here in this set. So H represents heads, and the numbers represent the numbers on the die. So notice that there are 2 times 6, which equals 12 total outcomes. So 2 sides to a coin, 6 sides to a die, 2 times 6, 12 total outcomes. Out of these, only one is the desired outcome, so the probability is 1/12. So this example is looking at 2 independent events. Here's the definition of an independent event. Events A and B are independent events if the probability of event B occurring is the same whether or not event A occurs. So basically they don't affect each other's probability. Here's example 7. The question is, are these events independent? First we have A. A fair coin is tossed 2 times. The 2 events are 1. First toss is a head, and 2. The second toss is a head. Well, the answer is the probability that a head comes up on the second toss is going to be 1 out of 2, regardless of whether or not a head came up on the first toss. So these events are independent. Part B says the 2 events are 1, it will rain tomorrow in Houston, and 2, it will rain tomorrow in Galveston, which is a city near Houston. Well, the answer to this one is that these events are not independent because it is more likely that it will rain in Galveston on days it rains in Houston than on days it does not. And part C says you draw a card from a deck, then draw a second card without replacing the first. Well, the answer to this one is that the probability of the second card being red depends on whether the first card is red or not. So these events are not independent. When 2 events are independent, the probability of both occurring is the product of the probabilities of the individual events. Here's the formula on this slide. So we say probability of A and B for independent events. So it says if events A and B are independent, then the probability of both A and B occurring is probability of A and B equals probability of A times the probability of B. And this is where the probability of A and B is the probability of events A and B both occurring. Probability of A is the probability of event A occurring, and P of B is the probability of event B occurring. So just remember that these are the notations that we use for probability. It's like function notation from algebra. Here's example 8. It says, in your drawer you have 10 pairs of socks, 6 of which are white, and 7 t-shirts, 3 of which are white. If you randomly reach in and pull out a pair of socks and a t-shirt, what is the probability that both are white? Well, the probability of choosing a white pair of socks would be 6 out of 10 because we're told that 6 of those pairs are white and we have 10 pairs total. The probability of choosing a white t-shirt, we know, would be 3 out of 7 because we're told that 3 of the shirts are white and there are 7 total shirts. So if we follow the formula that we just saw on the last slide, First of all, we would consider that these two events are independent. Drawing a pair of socks does not affect the probability of drawing a shirt. Then the probability of both of these things being white would be the product, 6 out of 10 times 3 out of 7, which would give us 18 out of 70, which simplifies to the fraction 9 out of 35.